Okay, this is just a little more about polynomials. We're talking here about the end behavior of polynomials and a little more about the multiplicity of the roots. Polynomials are nice curvy functions that look like these guys. These are all polynomials. The leading coefficient and the degree determine where these arms go. Do they point up? Do they point down? And so forth. So together, leading coefficient together with the degree determines what kind of picture we're going to have. Like here, in this middle one, both arms go up. In this third one, both arms go down. In this first one, the left one goes down, and the right one goes up. Okay, so that's what our goal was, determining where the arms go. What's happening for really big x's? The question is, what are the y's doing when x gets really big on each side? So we got 4 possibilities for end behavior. And here they are. The left side can go up, right side up. So both up, or down here at the bottom, both down, or one up and one down. Okay. Here's our first possibility. If the leading coefficient's positive and we have even degree, both arms will go up. Every even-degreed polynomial kind of looks like x squared with some extra wiggles in the middle. X squared is a perfectly good polynomial. So positive leading coefficient with even degree, both arms will go up. If we have a negative leading coefficient, we just take that guy and flip it over. Both arms will go down. Even degree, negative coefficient, both arms go down. If we have a positive leading coefficient and odd degree, then we're basically going to look like x cubed. All odd degreed polynomials look like basically x cubed with some extra wiggles in the middle. So in this case, positive leading coefficient, odd degree, the left arm goes down, the right one goes up. If we have a negative leading coefficient, we just flip that guy over. It'll go up on the left and down on the right. So negative leading coefficient with odd degree, left arm's up, right arm's down. Here's the easiest way to remember all this. Here's a nice summary. If you have an even degree, your arms go the same way, either both up or both down. Even degree, they both go the same way. Odd degree, you get one of each, one up and one down. If you have a positive leading coefficient, no matter what, if the leading coefficient's positive, your right arm goes up, and if it's negative, your right arm goes down. The other one depends on whether it's even or odd. So here are the 4 possibilities. Odd degree, they're going to go opposite ways. Positive goes down, up. Negative goes up, down. Even degree, they both go the same way, either both up or both down. And you just have to memorize those 4 rules. Okay, for example, we've got this polynomial that's in expanded form. Our degree is 6 and our leading coefficient is negative. So negative leading coefficient, I don't care if the leading coefficient is odd or even. I only care if it's positive or negative. Negative leading coefficient, even degree, 6 is even. So both arms will go down. That's a typo, that should say down. Both arms, and I fixed it. Both arms go down. Here, leading coefficient is positive 7. Don't care if the 7's odd or even. I only care positive or negative. Positive leading coefficient, odd degree. Degree is 5. So the left arm goes down and the right arm goes up. Here's another example. We have a negative leading coefficient. We got to count our degree here. We're in factored form. So we have to add up all our little exponents. The degree is not 7. It's 7, 8, 9, 10, 11. That's an odd degree with a negative leading coefficient. The left arm goes up and the right arm goes down. Because it's odd degree, they go opposite ways. Because the leading coefficient is negative, the right arm must go down, meaning the left arm has to go up because they go opposite ways. Okay, the multiplicity of a root tells us what happens to the graph as we hit that x-intercept. Real roots give us x-intercepts. The multiplicity of the root, whether it's even or odd, tells us whether we're going to cross over the x-axis or bounce off the x-axis at that particular root. When the multiplicity is odd, we're going to pass right through the x-axis. But if the multiplicity of a root is even, the graph will come in, touch the x-axis, and then bounce back either down or up, depending on which way it's coming. Okay, so let's look at this guy. Our leading coefficient's negative. Our degree is 7, 8, 9, 10, 11. The root here, 3, has a multiplicity of 7. 7's an odd number. So when the graph is coming in toward 3, the possibilities are the graph could come in, it's coming from this direction, and bounce off the x-axis, like a ball coming in, hitting the ceiling and bouncing back down. Or it could touch the x-axis and just keep right on going straight through. Because our multiplicity is odd, we pass through at 3. Odd multiplicity, we pass through. Even, we bounce off. Same thing here at 1. At 1, the multiplicity is 1. That's an odd number. The graph was, it looks really steep here. That's just because I'm zoomed in. The graph was coming down, goes right through the x-axis. Same thing at 5. The graph is coming from above, goes right through the x-axis because of the odd multiplicity. But this guy here, the root -2, has a multiplicity of 2. 2 is an even number. So at that x-intercept, -2, 0, the graph will bounce off the x-axis. So the graph comes down, hits the x-axis, and bounces back up. Instead of passing through, the graph bounces off. Even multiplicities, we bounce. Odd multiplicities, we pass through. Okay. Here's another example. I've got 2 roots, 4 and 6. 4 has a multiplicity of 2, 6 has a multiplicity of 3. So really I have 5 roots. I've got 4 twice and 6 3 times. Notice here, for end behavior, the leading coefficient is positive. My degree, 5, is odd. So look at my end behavior. Left arm down, right arm up, up. Odd degree, the arms go opposite ways. Leading coefficient is positive. So the right arm goes up and the left arm goes down. Okay, now this root, 4, has a multiplicity that's even. So when the graph comes in, it's going to hit the x-axis at that intercept and then bounce back down. Even multiplicities, the graph will hit the x-intercept and bounce. This x-intercept at 6, 0 has a multiplicity of 3. So we're not going to bounce back at 6. We're going to pass right through the x-axis at 6. Evens bounce, odds pass through. We're talking about the multiplicity, not the root. Sorry. I don't care if 6 is even or odd. I don't care if the root is even or odd. I care if the multiplicity, the little exponent, is even or odd. Okay, in the next video, I'll be putting all this together and actually graphing polynomials. That should be popping up on your screen right now. For right now, though, we're just looking at end behavior and bouncing and passing from multiplicity.